The time has come to finish our practice final. Let's do it. Number 16, use completing the square to rewrite the function in vertex form. So what we have is a quadratic function in standard form, and the only thing we're being asked to do is rewrite it in vertex form, and in order to do that, we have to use completing the square. Read the information on the board to help you solve this. And now let's check your work. First, we need to set this quadratic equal to 0. So we set f of x equal to 0. And the steps for completing the square are to first move the constant to the other side. So we subtract 12 on both sides. So we have our constant on the left and a binomial on the right, which is fine. But in order to complete the square, the whole term completing the square comes from complete the perfect square trinomial, referring to what we see on the right here. Now we have a binomial. How do we make it a trinomial? Well, we're going to use this formula, b over 2 squared. You've seen it before, and that's going to help us find the missing magical term that's going to make this a perfect square trinomial. So we take b, which is the coefficient of x, plug it into our formula, we divide, and then square to give us 100. That's the key component we need. We add 100 then to both sides of the equation because, as you've always learned, whatever you do to one side of an equation, you have to do to the other. And now, not only do we have this in a more resolved form, but we have a perfect square trinomial on the right. So we add these together. That's quick and easy. And we want to look at this perfect square trinomial and remember how to rewrite it. Well, that's a factoring pattern you learned about before. So let's rewrite this as a binomial squared. To do that, you take the square root of the first term, x squared, which is x, and then the square root of the last term, 100, which is 10, and then you put them inside parentheses squared. So our x, our 10, and it's squared. But how do we know it's negative? Well, look back to your perfect square trinomial. If both of these signs were positive, this would be positive. But since one is negative, this is negative. Okay? So the bottom line, if there are any negative signs here, this is minus. And if you wanted to check your work, you could actually multiply these together, right? You could do x minus 10 times x minus 10 with box method or FOIL. And if you get what you started with, you know you factored it correctly. So ultimately, completing the square is a factoring technique. We did that right there. Everything looks good. It checks out, but we need it now in vertex form. And remember, vertex form means the constant is also on the same side of the equal sign as everything else. So I'm going to subtract 88 from both sides, leaving me with 10 or x minus 10 squared minus 88, and that is set equal to 0. Well, we only replaced f of x with 0 so we could complete the square, and now it's time to bring f of x back. So there is our vertex form. Number 17. A timer is started, and a few moments later, a model airplane is launched from the ground. Its height in feet as a function of time in seconds after the timer was started is given by the equation h of t. How long after does it reach its maximum height, and how high is that? There's some helpful information on the board for you. You may also want to draw out what's happening a little bit. That should help as well. The first thing you should have noticed is the minus sign out front. That tells you this is a negative quadratic, which means a negative parabola. If we're looking at a graph, that means it looks something like this. Okay. So what do we do with that? Well, they want to know how long after does it reach its maximum height? Well, maximum height here would be the vertex, wouldn't it? How do we find the vertex? This looks oddly familiar. Doesn't it look a lot like what we just did right here? Yeah, so it's already in vertex form, meaning you take H, which is dishonest H, so the opposite of what you see, elevator V, and there's your vertex. That wasn't hard to find, but you got to know what these things stand for. Well, the x-axis is always time, so this is going to be seconds, and the y-axis in this case is feet. They want to know how long after does it reach its maximum height. So we're looking for the x value, which is seconds of 10, and the y value of seconds, which is 120, or sorry, of feet, which is 121. So what this really means is the airplane reaches a height of 121 feet, 10 seconds after it's launched from the ground. And number 18, a timer is started, and a few moments later, a swimmer dives into the water and then comes back up. The swimmer's depth in feet as a function of time is given by the equation f of t. Rewrite the formula in factored form to find out after how many seconds does the swimmer dive into the water and after how many seconds does the swimmer come back up. So once again, a graph may be useful. Give it a try. Okay, they said a timer is started and a few moments later the swimmer dives into the water. So x-axis we know as time. And there's t's here instead of x's, that's fine. So label t there and y there. So if time starts at 0, timer starts. A few moments later, diver dives into the water and then comes back up. Interesting. Another parabola. That makes sense. This is a quadratic, right? So what do they really want us to know? They want to know this exact moment the diver enters the water and this exact moment the diver comes back up from the water. So how many seconds? They want to know seconds. So is that going to be Y or T? T for time. X-axis is seconds. So they really want the X values, which is why we're going to factor this. Because remember, if you can factor, you can find the roots, aka the x-intercepts, which is exactly what we want. So we have a quadratic with a leading coefficient of 1. That means we should be able to use the x method, and we are. A times c goes on top, b goes on bottom. Then we want to write out a few factors of 18. 9 times 2, 3 times 6. You could find a few more. And then you want to do a little trial and error to find out which two will multiply to give you 18 and add to give you -9. And you'll find -3 and -6. How do we write our factored form? Usually you see x's here. So parentheses, a pair of parentheses with x in front. And we have the values -3 and -6. So that's what goes here and here. Now, like I said a moment ago, we factor to then find roots. You've done this many times this year. Set each factor equal to 0 to solve for t to get 3 and 6. So if we go back to our diagram, that would mean the swimmer dives into the water after 3 seconds and comes up after 6. So here's 3 and 6. So basically we're thinking of the x-axis as the surface of the water. And we've solved what we needed to solve. And we are done with the practice final. Congratulations. I went over all these details, deadlines, and information at the start of this practice final. If you go back to that recording, you will have a reminder on all of that. With that said, it's been a pleasure. I hope you enjoyed learning because I've enjoyed teaching. See you next time.